Welcome back. So next talk and last talk before the lunch break here is Mandi Walls talking about building security into your workflow with InSpec. So thanks for coming over, and a warm welcome to Mandi, please.
Okay, yeah, the last slot before lunch is never the good slot, right? Although the first slot after lunch, everybody's asleep, so, you know, either side of lunch is tough. But, yeah, I'm going to talk today about InSpec. Who am I? My name is Mandi Walls. I am currently the Technical Community Manager for Chef. I've been with Chef 5.5 years, so some days it feels like not that long, and other days you feel every single day. If you'd like to shout at me later, my email address is there, and I am LNXCHK on just about every social media out there except Snapchat, because I'm way too old for that silliness. So Chef, we started out in configuration management and system automation. We're based in Seattle in the US. We also have offices in San Francisco, London, and we actually have a small office here in Berlin. Ironically enough, those guys are actually giving a talk in London today. Planning is tough, right? So yeah, I'm actually based in Berlin or in London. I moved over a couple of years ago as we were launching over here. Sorry about all the air there. Okay. So what are we talking about? What do we care about here? Chef, for over the past 5.5, 6, 7 years, we've been working with a lot of customers and a lot of community members on speeding up their IT processes, making things more fast, more efficient, and doing that through system automation. That was our core product. That's how we got started. Over time, what we've learned is that increasingly every business in the 21st century is moving towards being a software business. So last year at ChefConf, this year's is next week in Austin, we had a really good keynote talk from the CIO of Alaska Airlines. So Alaska started out as a regional airline in the United States. They're based near us in Seattle. They recently purchased Virgin America, so you may have heard from them there. They are increasingly looking to get more efficiency, more flexibility, better customer service out of technology rather than out of these airplanes that they spend millions and millions of dollars on. So they have these large capital expenditures, plus all this regulation, and there's all kinds of politics involved in getting berths at US airports and all this other goofy stuff. All that aside, where they're getting efficiency and better customer service and all these other good things is out of technology. So what he said was, you know, they expect to be a software company with airplanes, right? So much of their current and future business and improvements and things come from software. So Chef takes a look at this. We have a number of product lines that we're working on. If you're not familiar with us, that's fine. We have our core Chef project, which was configuration management, systems automation. It's about 9 years old now. So that space is mature, you could say, in a large amount of ways, and is evolving into how things look for the future, whether we're looking at microservices and containers or serverless or all these other components. There's a whole lot of other things going on in the industry outside of what you traditionally need Chef or something for. So in addition to Chef, 3 years ago we launched a workflow project that is sort of continuous delivery with a different sort of accent on it. So it's really focused on integration and deployment. So we have that. And then we've launched 2 other projects. One of them is Habitat, which I'm happy to talk about offline later for folks who haven't heard about it, but it's application automation. And the other one that I am going to talk about today is InSpec. And we're really looking at InSpec from a compliance standpoint. So as we talk about that, that's sort of where we are. So as we were working with customers, we work with a lot of large enterprises as well as some digital-first folks, but also small companies that don't have a lot of extra personnel around to do a lot of these other tasks, these sort of secondary things. What we were finding was that we're helping the dev teams, the operations teams go really, really fast and do a lot of things and build a lot of stuff. And then it comes to security review and you're like, Okay, we got on their ticketing system. We are on their calendar for 6 weeks from now for a security review of this thing that we've been going really, really fast for in the early stages. And we saw this more and more, that there's lots of product features, lots of ideas, and then there's a security team or some kind of review or process that holds things back. And this little trickle gets to production eventually. So some places, they change around how they do this, and they take out the security review, and they do post-hoc scanning, right? And we're all familiar with this. There's a lot of products in this space. And what we found is that this is really too late for a lot of the things that compliance officers are looking for, that are things that you know ahead of time. We're not necessarily talking about intrusion detection systems or virus scanning or those sorts of things. We're looking at how the machine should be configured so that we don't get sued, because that happens, right? So this article from last year is about a insurance company, healthcare system, that installed a new server, didn't change the default configurations. And we're like, we're Chef, we know all about configurations. Like, we totally can play in that space, right? HIPPA, if you're not familiar with it, is a US healthcare insurance regulation about data protection, things like that. So these fines are non-trivial, and it happens in a lot of different spaces. And as new security regulations are launched in Europe and other things that we're looking at, all these things come into play more and more. So when we're talking to, say, all the team members for this sort of requirement set, they all have different things that they know, different resources that they use, different things that they need. And we found that compliance officers are really geared towards what's in those compliance documents. They may not actually be heavily technical people. They may be representatives of your auditors. They may be representatives of insurance companies that insure your business. They're not necessarily hands on the keyboard technical people. And that should be fine, right? They're there to make sure the boxes get checked. They often have their requirements in flat documents, things that don't necessarily have what we think of as a life cycle, right? They publish a PDF or maybe a set of Excel spreadsheets that have checkboxes in them that they check off. I saw one of these in DOS one time. It was horrible. Oh my God, don't want to do that. But these things are old, right? And they don't have like a constant update. But the operating systems and the platforms obviously are moving all the time. So they're having trouble keeping up with all these things. If you look at like something like the CIS standard, it's like hundreds of pages of PDF for each operating system that you need to look at. That's a lot of overhead. So those folks kind of live in their own world. And then you have your security team, and they're maybe your blue team or your white hats or whatever you call them internally, the folks that are doing your security audits, are working against the CVEs and things that might affect your platforms, all these other things that they have. A lot of the times, these folks are going for lowest common denominator. We see a lot of them, when we're working with them, work in Bash. So they're writing scripts that test for this team's Ubuntu stuff plus that team's Red Hat stuff. And then there's maybe one dude on the team that knows a little bit about Windows, and he's just ready to kill himself because it's crazy over there. But these folks have their own workflow and their own things that they're doing. And then we're the DevOps, and we come in and we're like, we're going to go fast, so hold on. And everybody else is like, you guys are nuts. We have all these other requirements to take care of. So enter something like InSpec, right? For the purpose of all these things, we wanted something that was easy to create for folks who may not be as technical as everyone else, but also easy to share, right? That was a big component of what came out of the early versions of this. So everyone could have their input into one platform, and that would then result in compliant architectures. So that became InSpec. So what our goals are with InSpec is that it's a human-readable specification language. There are tests in there, but there's also larger structures for organizing, sharing, and developing a life cycle around your compliance requirements. So we have these additional facilities for gathering up a lot of tests and reusing them as profiles so that I can say, all right, here's my global profile for Bank A for CentOS 7.3, and every time you have a machine or every time you're developing for it, make sure you pass all of these things. And then I can publish that internally on a file share, on an internal Git repository or SVN or whatever, and have it available to everybody who needs it. There's also extensible language built right in so that you can build your own rules for your own applications and systems, especially if you're building custom applications in or custom runtimes or using an older runtime that isn't necessarily supported or very popular in the rest of the industry. We see some of those still running around. And of course, it comes with command line tools for plugging into workflows and build servers and running audits and things like that. Additionally, Test Kitchen is another one of our projects. Hopefully you've heard of it even if you don't run Chef. So you can get fast feedback and local testing with InSpec in Test Kitchen. So as an example, something like SSH. We know that SSH is super important. We shouldn't be using Telnet anymore. God help you. But there's multiple protocols underneath SSH, of course. And not every new operating system has published with the best practices, and that's fine. Like, it's up to the upstream vendor to figure out what they want their default configurations to be. What it's up to me, though, is to know that when I'm deploying things, that the configuration that I'm putting out there meets all my security requirements, and to do that, I need to check it somehow and know what's out there. So, in my past life, I was a sysadmin at America Online. So I used to run AOL.com and a bunch of our channels and weird stuff like that. So we had a whole bunch of machines out there that had like 4 or 5 different platforms, and there was all kinds of weird stuff going on. And every now and then you get this command from on high, please check all your nodes for XYZ. And it'd be like, all right, well, here's bash in a for loop. Let's figure out what's going on. And we get things like this, right? You get an email from the security team, please check all your junk for something like this. So SSH supports 2 different protocols. The original version, version 1, is subject to a number of security issues. Please make sure all your systems are v2. So how do you do this? Like, what are you looking at? You have to identify the file and its location. If you're building systems using only system packages, hopefully stuff's in the same place everywhere. Maybe. If you've got some penchant for building your own stuff and putting SSH as a custom build because it has to support Kerberos or something weird into a weird place, then you have to find it. Where's that config file? How do I know where that is? Figure out some sort of fix. Am I just going to check it first, or am I just going to push a new config out just blindly and hope that nobody had a custom config anywhere? Maybe. How much risk do I want to take there? And then if I need to build something tomorrow, after I've already looked at my current machines, how do I know that the new one is going to be right? Are we going to rebuild all of our images? Is it time to do that? Maybe we only do that once every 6 months. But then do I have to remediate it at instantiation? So I build a machine, I have to go through this whole practice all over again. So hopefully you're using some kind of configuration management solution for all these types of changes. It's the checks that now we want to talk about. So as we've been working with more and more large customers and figuring out how our tools fit into their workflows, talking to the security folks has been super interesting, right? So how often do they actually get mandates from security? How often do you publish a new requirement, something to check, something to make sure that is right across the whole fleet? Sometimes they run single big scans and they get a report mailed out with a due date. By next Friday, please fix these 15,000 nodes. Usually it's only yearly, or maybe twice yearly, these big scans of the entire components. And then they have the next year to figure out how they're going to fix everything. We've seen this a number of times with banks, and it's like once you want to put all your money in the mattress after looking at some of these. So InSpec, we hope will help with all of this stuff, right? So InSpec lives at inspec.io. It's not under the Chef tree, so it's like beside Chef. It is open source, so the things we're going to talk about are all freely available for you to use. And the spec is a hint that it's built off of RSpec. So if you're familiar with the Ruby ecosystem at all, the testing languages and things like that, it will hopefully look a little bit familiar. So that's SSHD config that I was talking about earlier. How do we check that, right? So I have the ability to actually just ask InSpec to look for my SSHD config. In this case, I'm describing what I want SSHD config to look for, and what I want to look for in that particular resource. I can specify what I call an impact, what we call an impact. So from 0 to 1, how important is this thing? So you can actually publish test suites with warnings, right? So maybe 0.3 to say, we should keep an eye on this thing. It's not a hardcore impact, but we should know that it's out there. Maybe 0.6, think about fixing this thing. 1.0, please fix this right now. Red light, must do. So you can describe your impacts for all the tests that you create. And then you get into some of the human-readable pieces, the stuff that you can actually just sort of copy and paste right from these 500-page documents that the compliance folks have. Things like, what's the title of the thing that I'm checking, right? In this case, I'm looking for SSH version 2. So my auditor, when they're looking at this, they know I have a test for checkbox SSH version 2. And I have my description, and these can be super long, right? Cut, paste right out of that PDF file. Explain what's going on, why we're looking at it, maybe what the origin is of the request for test, right? And then I have the ability to dig around in that resource, that SSHD_config, and look at all the components that are in there. So they're key value pairs of some fashion, right? SSHD config is like plain text file. It's not super crazy. So in this case, I'm looking for a line that has its protocol as the characteristic, and then I'm going to compare it to the value that I'm requesting. In this case, the value should be 2. So it is geared towards having lots of different audiences for these particular tests. Folks that are pretty technical and are super into curly brackets, or folks that are not as technical and are really after making sure that what's in that description meets with the things that are required. So we do this via what we call resources. And InSpec includes a whole bunch of built-in resources. I think it's up to 60, maybe 50, 60 different built-in resources for services, system files, configurations. There's the basic stuff, so basic file checking and those sorts of things, but also these sort of more abstract ones like SSHD_config. I don't have to go looking for that file. InSpec under the hood takes care of finding it based on my platform. So I don't have to do all that extra work in my test. The built-in resources work on a number of different Linux platforms. We also have a bunch of stuff working for Windows. We actually published Tuesday night, or Monday, is today Wednesday? Monday night, an InSpec check for the WannaCry thing that was hitting. So looking for Windows components in InSpec as well. So the resource then has underlying characteristics, like that protocol that was in the example, that you can verify for your requirements. And the matchers work through dealing with what's actually in the file. So the abstraction layer gives you the ability to say, I want this, look at this config file, and then if it's a supported resource, InSpec will dig through there and know what you're looking for. So there's a number of more complex ones that are in there, like web server configs and this SSHD config and a couple of others that already know what that file should look like and how to manipulate and manage it. So there's my resource, SSHD_config. My compliance officers obviously don't care. They don't care if you're using Debian. They don't care if you're using Red Hat. All they care about is if you've got your SSH running, that it meets this protocol, and InSpec can figure out where the file lives and what should be in it. So the language that is sort of included is built off, as I mentioned before, sort of RSpec related things. And it gives you a set of tools for looking at characteristics of components of your system. Things should exist, like a file should exist. Hopefully Etsy Shadow exists on your machine. packages that should be installed, your firewall rules or something like that. Services that should or maybe should not be enabled, making sure NFS is turned off on your machines might be part of your compliance requirements. And also, sort of deeper things, looking at something like max log file, knowing how long your log retention should be on the individual nodes can be encoded into your profile. If you have tests maybe from your upstream vendor that are like, to check if your node is vulnerable to this vulnerability, run this script, and they give you a bash file. You can actually run that from your InSpec test and check the exit status on that, so that you know, yes or no, are my nodes vulnerable to this thing that's been published by my upstream vendor. We can also get into more complex built-ins, things that have a lot of dark magic in them, like limits.conf, right? Which that file is nuts, and every time I look at it, I have to open the man page in another screen, and like, what the hell's actually in here? But it can help you manage what's actually in there and know for sure that the components and the requirements that you have for limits for things like core dumping or memory or whatever all meet the same requirements that your resource officers want you to meet. So we can run inspect from the command line. If you want to install it by itself, it installs as a Ruby gem. So if you have Ruby on the system, you just install it that way. It's also part of ChefDK, which is our development kit that has all of our suite of tools built into it. It's kind of a beast. It comes with its own Ruby, so it's separate from your system Ruby, installs in its own location, and lives its own life that way. We can run our InSpec tests locally, so I can actually test a system if I'm developing here and want to make sure that the changes that I've made to my server XML or whatever still meet with my compliance. I can run tests locally, or I can run them remotely against another machine somewhere else. So InSpec logs in to that remote host and runs tests for you that way. So we can test a whole bunch of different targets. To run it locally, I just run InSpec exec in whatever my test file is. So it's super easy that way. I can just have them living in my application directory if I need to. If I want to run it remotely, it's using SSH for Linux, right? Like everything does. And so I have my identity file, I log into my remote node, and I can execute that test remotely via SSH. If I'm working in Windows, it'll run over WinRM. So if you want to run it remotely there, you have to make sure WinRM is enabled. If I have a Docker container, I can also launch it and use the Docker container as a target to make sure that nothing weird got into my container that way. So a couple different options depending on where in your life cycle or how you want to make use of InSpec that way. What it looks like when I run it, if I have a failure, I get a summary at the end of the run. So I have no successful ones in the first option there and one failure. My return code ends up being non-zero. So if I want to add this to a pipeline of other tools or run it under my build system or whatever, I can make use of the return code to just harvest the output that way. And then if I have them all successful, and they have to all be successful, so I get 0 failures, I'll get my 0 return code and everything comes back okay. In Test Kitchen, what also runs there, I add my verifier name of InSpec. If you're familiar with Test Kitchen, that just goes into your kitchen.yaml file. So what about server spec? Like if you're familiar with server spec, you're probably sitting there thinking like, server spec does all this. Why do I care, right? Nods, I get it. The server spec's awesome. We use server spec. It was part of our suite for a long time. We were using it as well. InSpec ended up being sort of a superset of what server spec does. So there's a sort of different audience that we added to the requirements for the tool that we wanted, and that's these sort of compliance officer folks who have text-based requirements, and it's a different sort of endpoint for what these tests need to do and who they need to be for. And so part of that ends up being about the next thing I'm going to talk about, which is building up profiles, sharing them, depending upon them, and using them across multiple teams and workstations rather than just inside the application for a single development stream. So we're looking more at sort of global or universal compliance requirements versus the more granular things that ServiceSpec and sort of the previous versions were looking at. So one of our engineers actually wrote a blog post about sort of the life cycle of how they put together InSpec from ServiceSpec and what it looks like to take a look at both of them that way. So this was from 2005. The originations of InSpec were actually a dev team here in Berlin that Chef, the company, bought and absorbed their IP. And one of those engineers wrote about their evolution of what ServiceSpec was, what InSpec became, and there's some other deeper like library stuff in there for folks that are super pedantic about that. There's different changes to how InSpec works and its abstraction layers. But the super interesting part is these profiles. And when we're working with a lot of different applications and you have a lot of test suites that only live inside the application's repository, it can be a lot more work to manage the additional test suites on top of the applications, and maybe you have the components for your infrastructure as code pieces or whatever you're using there. So you have a lot of moving pieces and some potential for duplication. So profiles came in and it allows you to package up all these sets of all these tests. So I may have 20 different applications that are going to be launched in Tomcat somewhere. So I have a set of requirements for the security and the configuration of my Tomcat systems, and that's fine. So I want to be able to share those in a place where my compliance officers can verify that they're correct, my engineers can pull them into their dev stream, my operations folks can use them during deployment to make sure things are okay over time. So I have the ability to share all these things out in an easy way. They're building around these controls, which is part of what we looked at earlier, that then are audited against your specific requirements. Each file has multiple, sometimes lots of test files included, and lots of individual tests. So some of these can be very, very large. When you're looking at something like the CIS example, there's 20 chapters or something like that about phases of the system that it's looking at, and then there's individual tests underneath those. It's the matrix of it's gigantic. So you can also depend upon other profiles that are outside your current working set. So my engineers can know if you're going to use Test Kitchen, require this particular test suite that we saved on our internal GitLab server or whatever, and pull it down and run it every time you run your tests. So we can publish these then and include them in all of our local work. There's more documentation about the dependencies and resolvers and things like that that go into the profiles in the InSpec documentation. But just quickly, things that are in the profile. So InSpec comes with a tool to help you actually write them. So InSpec init will help you write put the skeleton together for where your profile has to be set up, so you don't have to remember the directory names and all that junk. And as we build more tests, we add them to the controls directory. So that's where they all end up living. If I have my own resource that I've built, so the config file for this runtime that we built internally, right? No one else knows anything about that, so it's obviously not a built-in thing. I can add that into the libraries directory and publish it out for the rest of my team to also consume. Working with my profiles, similar to what I was doing before. So InSpec exec is there to actually run the profile. If I want to check the syntax, I can run InSpec check just to make sure everything is kosher that way. But then to actually run it against my system, I use InSpec exec. What the controls actually then look like, they're similar to what we saw before, right? So one level up, I have this control, and this is part of my controls, the files that are in that controls directory. And this is actually just one test in a larger file of many tests. So they're sort of broken out in categories that way. In this one in particular, I gave it a name that probably relates back to the document that required it. In this case, OS-4. So I have a document that my compliance officers or the security folks, whoever I'm ingesting these rules from, has named operating system, and this is probably subheading 4, right? So I can relate everything back. So I have OS-4. We've decided it's impact 1.0, like we mentioned before. Title, description, super familiar. And then here's my describe. So earlier I had that describe SSHD config. That was sort of the top of this. We have one more layer of sort of metadata there to tell us that where these controls live. And here I'm looking at my operating system environment. I want to make sure that the local directory isn't part of the path, because attackers might drop something in there and it's easier to deal with. So I have 2 tests for that based on what is required by this particular security control. Okay. So now we have some time for what I hope will be a bit of a demo. So I have an example of sort of basic hardening. So the engineers that work on InSpec for us have published a couple of guidelines or a couple of shared profiles for figuring out and helping you sort of run through what it means to work with InSpec. So the example that I have is a CentOS 7.2 host. It's in my laptop, so it's Vagrant managed with Test Kitchen. I have a cookbook, because we're Chef, so the configuration management part of this is built in Chef. And it's something that the same engineers wrote, so these fit together. So I have an OS Hardening Cookbook, and then a Lynx Baseline InSpec profile. Both of these were shared in our community site called Supermarket. So they work together. This is the example config from my kitchen.yaml file. I have a run list that will let me include the OS Hardening Cookbook. And then I have my InSpec tests. And if you're familiar with just using server spec or other components inside of Test Kitchen, you know you have your local directories, right? And here's my profile. So I'm just going to download it directly from GitHub. So all of my other team members, my compliance folks, my security folks, can update this particular baseline, and I don't have to worry about ingesting it manually into all of my application pipelines. It will just come down because I can depend on it from this remote location. The things that are in the OS Hardening Cookbook are divided out by the pieces that they actually touch. So these are things that are going to change or look at configuration in my system, right? For stuff like apt or the limits.com file or login definitions, things like that, that are fairly common security requirements or security controls that folks should do when you're talking about taking just a bare bones installation and turning it into something that's a little bit more secure. So let's see if we can get it to go. Okay. Ooh, deprecations. All right. So what I have is my Linux system. It was already running, so I'd already started it up. And I have hundreds of tests in this sort of basic hardening component, right? So these are common things, making sure all of my security files are set for the right permissions, checking my login definitions, paths, password controls, kernel things, passed all that, yeah, that's pretty good. ICMP, just sort of basic stuff. And these are all stored in, where's my OS hardening one? There it is. And my baseline. So these are all shared in GitHub. This is the actual test suite. So there's things in here that we're sort of ignoring or making sure don't exist. Then we have my OS controls. So the one I pulled up earlier was OS 4. This one's OS 2, right? So I have lots of things that I can match out of a single component, right? So OS 2 is looking for owner and permissions in Etsy Shadow. And I can check all of these things for that particular resource on the system. It's all in one stanza of my checks. If I need to, I can still break things out by operating system, right? So in this case, Debian and Red Hat treat group readability of Etsy Shadow differently, and I can call that out if I need to. And these just keep going and going and going, and all sort of live in the same file. Okay. So now what if I want to clear these up? What I'm going to do is bring in the partner to the Lynx Baseline. So Lynx Baseline is just doing tests. It's just checking. So I booted up a bare bones CentOS box, didn't fix anything on it, and ran my Lynx Baseline. This is something I'd want to do if I were spinning up a new image or using a new image for the first time in my cloud, or we're rebuilding for updates in our own stuff on premise or whatever. And now I can actually run my hardening against it, and we'll see how that goes. We'll give that a minute. I think that one takes just over a minute to run. So as I mentioned before, things that are in the Hardening Cookbook, I'm going to go through, make some changes against my system. So what I'm hoping for, right, when I run it without the hardening, I'm just running a bare bones operating system. I've got my security requirements, or they've been published by my compliance team, and I run it and I'm like, oh shit, there's all these things that need to be fixed. In this case, this particular example, I think these hardening things were based on the NSA guidelines, so they're not completely arbitrary. Which I guess depends on your definition of the NSA. But I have about 100 that passed and then another 60 or so that failed when that all comes out. And what I'm hoping for after the next run, after it's been hardened, is to have no failures. So I'm meeting all of my security guidelines. That's what I'm hoping for. Let's see how it's doing. Okay. So it's made some changes. Oh, it stopped mirroring. Here we go. Okay. We made some changes in the system, some things that needed to be fixed. That's fine. I'm assuming someone who knows more about security than I do has done the heavy thinking about all of this stuff. It's been a long time since I've done any security work. So now I'm going to try my verify again and see what happens. There we go. So the things that were all bad before all got fixed.